right. Welcome to our Science and Global Change presentation, Hot Zones, Climate Change, and the Spread of Malaria. I'm Kat.
I'm Kelly.
I'm Kathleen.
And we're going to be talking about malaria. Look at that little guy. Ain't he adorable? So I want to start off by talking about what exactly is malaria. So it's caused by a parasite Plasmodium. The parasite gets inside your blood cells, but the way it's transmitted is by a female Anopheles mosquito that's been infected with said parasite. There are 5 strands of malaria: Plasmodium falciparum, Plasmodium vivax, Plasmodium malariae, Plasmodium ovule, and Plasmodium knowlesi. The most common strands of malaria are vivax and falciparum. Malaria and ovule are the more rare forms. And despite falciparum being more common, it is the more deadly strand. So I'm going to be talking about, the origin of malaria. It was originally discovered in Algeria by this man, Charles Louis Alphonse Lervan. He was a military doctor, and while he was stationed in Algeria, he was tasked to find the cause of what was plaguing these French soldiers. Spoilers, malaria. So he would be looking at their infected blood, and he would notice these spheres that would attach themselves onto the red blood, and these spheres were the parasite. On the right, we have an image of, the parasite. So you can actually get malaria in warm temperatures and high humidity. On the right, we have mainly the locations that you can be infected. We got Africa, Central and South America, Dominican Republic, Haiti, all other areas in the Caribbean, South and Southeast Asia, islands in Central and South Pacific Ocean. So what happens once you're infected with malaria? So after the Anopheles mosquito bites you, there'll be an incubation period. In this period, the parasite will start to develop and infect your red blood cells, even before the first symptoms appear. This period can last anywhere from 7 to 30 days. After that, symptoms can start off with fevers, chills, headaches, and can turn into more severe forms, like more severe symptoms, such as seizures, mental confusion, coma, and death. But despite this, malaria is very curable when diagnosed and treated quickly. And basically, your treatment really depends on your strand of malaria, your physical location of where you were bitten. This can help determine the drug resistance of the infection, your age, how sick you are, and whether or not you are pregnant or breastfeeding. And your dosages are weight-based. There are different treatments, like for severe malaria, there's IV. Comatose patients will get like a nasogastric tube. And for the less severe forms, you take an oral tablet. And after taking the medication, it typically takes effect after 24 hours. And during your treatment, patients should get 2 types of blood smears done, thick and thin, every 12 to 24 hours until the parasite is gone.
The balance between temperature and precipitation is critical for breeding and transmission of malaria vectors, and hence for the transmission of malaria. Therefore, in order to understand how climate change is affected by the spread of malaria, it is important to understand just how the climate is changing. Due to a rise of greenhouse gases in the atmosphere from the burning of fossil fuels, the climates around the world have been changing drastically. Africa has been no stranger to this, where changes in Africa's climate have manifested as higher temperatures, elevated humidity, and deviation from previous rainfall patterns, and an increase in the frequency of natural disasters. Average temperatures in southern and western Africa have been increasing around 0.4 degrees Celsius per year annually, with a projected temperature increase of 4.6 degrees by the end of the century. Additionally, due to disruptions in the El Niño cycle, parts of Africa will have increased humidity levels, causing unpredictable rainfall patterns, with an increase in droughts in some regions and extreme rainfall in others. With these changes also comes an increase in the frequency of natural disasters throughout Africa due to climate change. Additionally, it is crucial to understand just how mosquitoes spread malaria and how mosquitoes and the Plasmodium parasite are influenced by temperature. Mosquitoes primarily lay eggs in stagnant water caused by rainfall, where the ideal water temperatures for hatching are between 24 degrees and 30 degrees Celsius, and the optimum water temperature for the larva to pupa transition is between 22 degrees and 26 degrees Celsius. The relationship mosquitoes have with temperature is one of the key reasons climate change has such a significant impact on malaria transmission. The balance between temperature and precipitation is critical for breeding and transmission of malaria vectors, and hence for the transmission of malaria. The Plasmodium parasite also has a tight relationship with temperature. The ideal range for temperature for parasite development is between 25 degrees and 30 degrees Celsius. However, the minimum and maximum temperatures for survival are between 18 degrees and 40 degrees Celsius. While there is quite a broad range where the parasite can develop, even slight differences upon the temperature at which the parasite develops can hold a significant impact on the developmental period. Where at 25 degrees, there is a 12-day development period, but at even a 5-degree lower temperature, there is an over 30-day development period. Therefore, at higher temperature levels, less time is required for parasite development, which increases the probability of spreading infection. Now that we know a bit about the science behind the spread of malaria, how does climate change affect it? This figure shows the projected change of malaria mortality due to climate change, where the median change is projected to be a 2.5% increase by the end of the century. This is largely due to the higher temperatures and humidities fostering an increasingly optimal environment for the mosquitoes and the parasite alike. Areas that currently generally experience low malaria transmission rates may see differences attributable to increasing temperatures that rise to the optimal level for vector breeding. Currently, trends show that malaria-spreading mosquitoes elevate their range by 6.5 meters per year and 4.7 kilometers away from the equator each year. These trends are only elevating due to climate change. As the temperatures increase, less time is required for parasite development as well, which also increases the probability of spreading infection. Additionally, humidity plays a huge impact since mosquitoes lay eggs in stagnant water caused by rainfall. So as extreme rainfall events are becoming more common, the mosquito population will increase, leading to increased malaria transmission and mortality. Extreme rainfall events, as well as general increase in natural disasters, will affect the human population as a whole, where recovery from natural disasters can cause a decrease in access to healthcare and less focus on the malaria problem entirely.
To view the scope of malaria's impact from climate change, we must begin to look in the past. Within the 1900s, a greater effort in understanding and addressing the issues from malaria began as seen in the figure on the right, which began approximations on the spread of malaria in pre-1939 and eventually collection of data after that same year. Gray areas represent little to no transmission, while dark pink areas represent stable transmission rates. The 1900s also sports the beginning of malaria trends, such as an expanded geographical range of the mosquito vectors that transmit malaria, an enhanced duration of sporongony, or the parasite's multiplication in the mosquito, and the creation of heat islands with more favorable breeding conditions. Since the 1900s, significant improvements have occurred in the fields of medical technologies and agricultural methods, while global warming has continued exponentially, impacting the world around us in all aspects. Specifically, successes and setbacks since the 1900s include improvements in control efforts from significant funding and success intervention methods, a persistence of challenges with insecticides resistance and healthcare access gaps, and the continuation of climate change, complicating control efforts and shifting transmission patterns. The data on the left is from the Malaria Atlas Project. an international research organization that collaborates with the World Health Organization's Global Malaria Program, as well as the Clinton Health Access Initiative. Their goal is to map out the current burdens of malaria and determine prevention. The figure from 2015 outlines the hotspots, or the occurrence of malaria-carrying parasites in the mosquitoes, with blue indicating around 20% and 60% in the yellow and pink highlighted areas. Compared to the figure from 2020, just 5 years later, a visible increase in the concentration and geographical movement upwards demonstrates a glimpse into the current trends. These transmission patterns continue to change the known precedent of the spread of malaria. A few of these effects have been outlined here. To begin, an expanded geographical range. Malaria is now spreading into previously unaffected areas of Africa or new hotspots. Different seasons. Changing weather patterns, in particular greater rainfall, lead to longer and more prolonged breeding seasons. Changes in mosquitoes. Alterations of the mosquitoes' migration and behavior and natural habitats, shifting further north. Deadlier impact on vulnerable groups. Those in areas with a lack of accessible health care and with existing conditions are at the highest risk for contracting malaria. Harder to control malaria spread. Insecticides are less effective in warmer temperatures, allowing mosquitoes to gain a further resistance.
All right. To summarize everything, basically, climate change is changing the heat and humidity to the mosquitoes' benefit. And between 2030 and 2050, WHO expects there to be an additional 250,000 deaths per year from diseases, one of which includes malaria. Thank you.